Hello, so today we are going to do problems from weekly contest 347. The first problem is remove trailing zeros from a string. So basically you have a number here represented by a string. And then we want to return the number without the trailing zeros, right? And we want to return it also as a string, okay? So that means basically trailing zeros, we want to remove them. So we take here, we take these two, we remove it. And so now we have these left, we return. Here there are no trailing zeros, so we don't need to remove anything. The problem says you don't have any leading zeros, so you don't need to worry about a number that is all zeros or a string that is all zeros. So how do we tackle this? Well, the simplest way to do it is just to go from right to left, right? And keep going until we encounter a non-zero. And then just return the string up to that non-zero, the first non-zero. That way basically we ignore all the trailing zeros. So that's a pretty simple solution. Let's just implement it here. So what I mean, just to show you again, is here we can just go through I and take a traverse here using an I position and just keep going to the right until we find the first non-zero position. So that would be here. And then we can just return the string. So this is, remember, this is a string. Let's call it num actually. Then we can return up to this position. So to do that, you could just do I+1 like this in Python, and that will return you this, and that will be equivalent to sort of removing the first zero numbers from the right. Okay, so that's what we'll do here. So we will just go through. Let's do it like this. So we'll go through I starting from the length, and the length will just the length of the number, right? And then we'll just go while we haven't reached the end. So while I is bigger or equal to 0, we need to decrement, but we want to stop if we encounter the first non-zero. And so the first non-zero, we want to stop here and we want to break. Okay, and then at the end here, what we want to return is just the number as we said up to I. Okay. And that should work. Let's submit, and that passes fine. And then in terms of time complexity, it's just O of n being the length of the number represented as a string. Now a better approach that I want to show you here is actually a little bit clever. So we can just convert this to a number, and as long as the number modulo, let's call it n, as long as n modulo 10 is equal to 0, that means there is still a trailing 0, right? Because if number modulo 10 is equal to 0, that means the number ends with 0. So how do we remove the 0? Well, to remove the 0, you just divide by 10, right? Because 100 to remove the 0 is just divided by 10, you get 10. To remove 0 from 10 here, you just divide it by another 10, you'll get 1, right? So that's sort of the idea here, is we'll keep checking if, as long as it's divisible by 10, that means there is a trailing 0. And so here, the first operation, we find that it's divisible by 10. So we assign it, we divide it by 10. And so we get now like this. It's still divisible by 0. And so we divide it by 10 again, and we get this number. And then we'll find that it's no longer divisible by 0. So we'll just return this. So how do we do that? Well, just like this, we want to convert it first to a number, and then while this number is divisible by 10, we want to just divide it by 10, okay? And then at the end, we want to just return that number, but remember the problem asks us to return it as a string, and so we just need to convert it back to a string. And this should work, and this passes as well, okay? So yeah, that's pretty much it, I think, for this problem. Please like and subscribe, and see you in the next one. Bye.